Welcome back. We're not going to rest until we get our smart contract to successfully ape into every curve pool, and we're going to use Brownie's interactive debugging to get us there. Previously, we had a lot of luck getting into all of the curve pools, at least the ones that accepted die, but these were just the classic curve pools through the registry. Any of these orange factory tag pools, we can't get into yet. And if you notice, by reverse sorting by TAPY, that's most of the pools. We can't get into IBBTC, CVX, CRV, fixed forex. All the top yielding pools are off limits to our Margarita token. Let's fix this. I've gone ahead and updated the smart contract logic, and I'm at the point where we need to test it. I'll walk through the smart contract in a second, but integrative tests take a long time to run, so we want to get this running as soon as possible. From line 7 to 21, you can see the previous test that we ran. This is going fine. It's excluded the pools that it issues, but in most cases, we're able to get in. This will pass. We don't want to deal with this. Line 24 and onward, we run into our new test. This is a test I wrote to basically replicate the logic of the previous one, but we're looking at the factory instead of the registry and dealing with some of the similar functions there. I'll walk through this test again in a second, but again, we want to get this test running. We don't want to run this first test. So there's a few things we could do. We could add it to a new file, get rid of it here. We could comment it out. We could move the test below above it. But Brownie's PYTEST has a really helpful pytest.mark.skip. And when you run that, it's just going to skip the test. It allows a lot of interesting capabilities. You could conditionally skip tests. You can pass reasons why you're skipping the test. In this case, we're just going to add the flag, get rid of it, and we're done. We would also like to be able to deal with one other issue here. Hypothesis by default starts with 50 pools. There's 66 here. So we'd like to up that number to make sure that we're testing each pool, maybe even multiple times. Now we could change this globally. If you want to do that, you'll edit the Brownie config file, but we don't want all of our hypothesis tests to run slower, just this one. So by importing settings from hypothesis here on line 4, we're able to deal with individual one-off cases. In this case, it's the max examples, and let's knock that up to 100. There's a bunch of interesting settings, one of which you might look at is report multiple bugs equals true, if you'd like to run through and watch it fail multiple times. So we're going to go ahead and run Brownie test, just all the integrative ones, and make sure to pass the interactive flag. So if it fails, we'll be able to hop on the command line and see what's going on. While it is running this, first thing to note is that when this pops up, it's passed an S flag to say it skipped the first test. Now it's on the second one. So going back over here, most of the logic is the same. It's just using the factory in place of the registry. We also want to check if the pool total supply is empty. And other than that, we go ahead and stake an ape. Basically the exact same test. Contract also uses pretty similar logic. In most cases, as mentioned, this is not a Viper tutorial, but we'll just go ahead and walk through it so you can see. In most cases, the factory functions very similar to the registry, but there's a couple of nuances which, for the time being, just to get the code working, I basically forked it, whether we're dealing with the registry or the factory. So I added a new interface. The address provider is being used to pull in the most current copy of the factory. We are now storing the factory. The load coins function, we previously forked whether it was using underlying or not. In this case, we are forking it whether it's using underlying and whether it's using the factory. It's going to be a common theme in the contract. The get coin index function also had to be modified. In a lot of cases, basically, we're just passing this use factory flag where we were also passing use underlying. When we initialize our contract, we set the factory. The bulk of the changes is right here. When we ape in, previously we had the capability of setting the flags based on whether it was a meta pool or not. We're going to be doing basically the same thing here, but in this case, we're going to be looking at all of them. We'd like to see if the factory is a meta pool or not. If it is, then we pass the flags appropriately. Finally, not all the pools have rewards. We actually saw this was a test that failed in the previous one. One of the pools did not have a rewards gauge hooked up to it. A lot of factory pools don't. So we're moving our logic within the test. So it's slightly different logic to actually get the rewards gauge in the first place. And once we got the rewards gauge, then we're checking to see if it's the zero address. The zero address is a built-in constant. You can also import it and work with zero address in Brownie. If the rewards address is the zero address, then we skip. Otherwise, we ape it. And our test has failed. We get a weird integer underflow error, which is a little bit confusing. Looking at it, it looks like the issue came up with pool 46. So what is pool 46? Let's take a look at the curve factory pool 46. And just eyeballing it, we see that this is some weird W Coinbase IOU to die. And right off the bat, it looks funky. Put in $1, get out a penny. It's giving you a warning the exchange rate is too low. And looking at it, it looks like there's a total of 1 penny deposited in this pool. So here's why it's failing. It has a supply. Someone supplied it with a measly penny. So it's not triggering any of our supply flags. But it is, in fact, having an issue with actually running it, and we're giving it like $5,000. So there's a few ways we could attack it. We could lower the amount that we're passing to the pool. I've went ahead and written a helper function just called isPoolLow. I'll check in the repository, but I won't walk through the logic here. You can also just right here say if is pool low factory pool and pass die.balance of Alice. And if it's low, then we'll return. One other thing while we're here on this interactive mode, if you need more debugging information, take a look at the most recent history and call a traceback. This is telling me that this happened in the contract stake.vy on the specific line. It's specifically line 137 where we're adding liquidity. So this is really useful if I want to take a look at what's going on here. And perhaps I want to add a check-in here. Perhaps up here where I'm writing assert statements, I'm going to write a new one to say if the balance is hefty versus what's in there, revert right here. This is where using the interactive capability can be really useful. And this traceback is one of the best tools that you'll have. Of course, the history transaction objects have a bunch. This is just one I find myself relying on a lot. So because I've updated my staking test, I can go ahead and run it again. And it's passed. Our contract's coming together. Stick around, a lot more we can do with it.